In addition to the marginal frequency that we saw and the conditional relative frequency, there is also something called joint relative frequency. Joint relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable. Joint relative frequency helps answer the questions involving both of the variables in a two-way table. Okay, this is different from marginal, which tells you about only one of the variables, and it's also different from conditional, which gives the percent or proportion of individuals that have a specific value for one categorical variable among individuals who share the same value of another categorical variable, right? That's the condition. So we're going to look at an example here. This is different than the superhero example. This is an example of showing whether or not people are members of an environmental club and their snowmobile use. So first question, what percent of people in the sample are environmental club members and own snowmobiles? So this is different from the other ones we saw because I'm specifically asking about two different variables. The way you figure this out from this two-way table, you look to see where those two variables overlap in the table. In this case, they overlap at here, 16. Yes, they're in the club and they own snowmobiles. And then you're going to divide that by the grand total of people. Now, you can leave your answer as a fraction or a decimal, but they did ask for a percent, so you can convert it there. Next question. What proportion of people in the sample are not environmental club members and they never use snowmobiles? So that's going to be 445, where those two particular events line up. And again, out of the grand total of 1526. So that becomes a proportion of 0.292. It's good to round to 2 or 3 places, sometimes 4. You don't want to just round to one place, though. Notice how this is different than if we had done marginal, right? A marginal would be like what proportion of people are not in the club, right? That would have been 1221 out of 1526. Or if we had done conditional, you know, what percent of people not in the club have never used snowmobiles? That's different. Joint relative frequency is usually going to use the word and, right? They're not just giving you a single condition. A quick AP exam tip for the relationships between two categorical variables. When you're comparing groups of different sizes, make sure you use relative frequencies, right? These are your percents or your proportions, instead of frequencies, which are counts. This is especially important if they're not the same size, as I said, because you might say, oh, this one has more. Well, of course it has more. There are more people in that group to begin with. So make sure to avoid statements like more club members never use snowmobiles, when in fact you mean a greater percentage of club members never use snowmobiles. Now, there are going to be 3 different types of graphs that are appropriate for categorical data, just like we saw in the superpower or the environmental club snowmobile examples. You're going to have your side-by-side bar graph, a segmented bar graph, and then also mosaic plots. A segmented bar graph displays the distribution of side-by-side bar graph displays the distribution of a categorical variable for each value of another categorical variable. The bars are grouped together based on the values of one of the categorical variables, and they are placed side by side. Here is a visual of a side-by-side bar graph for the example we were just talking about, the environmental club and the snowmobile use. You can see how they are touching here. In a regular bar graph, they are spaces between, but because it's a side-by-side, they truly are right next to each other. And we divided into either no, they're not in the club, or yes, they are in the club. And then the 3 options for snowmobile use are displayed there. Again, notice how it's percentages and not counts, so you can truly see how they compare. Another appropriate graph for categorical data, if it's a two-way table, could be a segmented bar graph. This displays the distribution of a categorical variable as segments of a rectangle with the area of each segment proportional to the percent of individuals in the corresponding category. So here's a visual of that. It's the same graph as the side-by-side. It's just now they've been stacked on top of each other, right? You can see if you were to take the side-by-side and just plop them one on top of each other, it would make the segmented bar graph. This helps when you're looking at association specifically. As you can see, the two things are not the same. So you can see there is an association between whether or not you're a club member and then your snowmobile use. The third one is a mosaic plot. This is just going to be a modified segmented bar graph, but the only thing that's changed is that the width of the rectangle now is now proportional to the number of individuals in that category. So up here in the segmented, they had the same width. So because they're percentages, I don't know which group was bigger in number, but because the width of the no segment is much wider, that tells me there were a greater proportion of individuals in that category than the yes category. Quick recall about association. We know there is an association between two variables if knowing the value of one variable helps us predict the value of the other. So as I mentioned, if you're looking at this segmented bar graph, the distributions are different, right? If I said, someone is a member of the environmental club, that tells me they're more likely to have never used a snowmobile because that's what we see from the graph. Whereas if knowing the value of one variable does not help us predict the value of the other, then we know there's no association. Visually, what that's going to look like is having the two graphs look identical, right? Knowing that you're in the environmental club or not doesn't change whether, you're more likely to have owned a snowmobile or not, okay? So that's visually how you can tell. You can also do that from the percentages from your two-way table. This concludes our section on analyzing categorical data. By now, you should be able to make and interpret bar graphs for categorical data, identify what makes some graphs of categorical data misleading. You should be able to calculate marginal as well as joint relative frequencies from a two-way table, and calculate conditional relative frequencies from the two-way table. You should be able to use bar graphs to compare distributions of categorical data and then describe the nature of the association between those two categorical variables. In our next section, we'll be looking at ways to display quantitative data. So this one was all about categorical data or qualitative data. And then the next section is going to be about displaying the quantitative data.